Hello, you guys. Today we're gonna do Epicoclus AB 2011. Question number one. For the particle between 0 and 6 is moving along the x-axis. The particle position s at t is not explicitly given. The velocity of the particle is v at t equals 2 sine e to the power of t over 4 plus 1. The acceleration of the particle is given by a of t equals 1 half e to the power of t over 4 cosine e to the power of t divided by 4. And not only that, they also give us s x of t over position x of 0, which is 2. So now in the question number one is the is the speed of the particle increasing or decreasing at t equals 5.5, and this is specified to give a reason. So what we want to do is basically b of 5.5 and 8.5. I'm sorry, I'm just a little sick. And so once you put b 5.5, you should be getting negative 0.4537. And the way you should do it on the calculator, you type velocity and then you go second. Just graph it. As you can see, the graph is right there. Then you go second trace, and then you go to value, and then you just implement the value 5.5 into it, press enter, and then it should give you negative 0.453 blah 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 blah. So now we're gonna put acceleration into the E graph, and then we shall graph it. So just give me a second. I'm kind of getting a bit lost on where everything's located. So I'm sorry about that. So once this calculator gets the graph, let's see. Okay, so you see it's graphing right there. We don't really need to zoom in, zoom out. If you don't know, if you want to do it, go for it. So we shall do the same thing. Go to value and then implement imply the 5.5, and we should get negative 1.35. So in going back to problem says to give a reason. So the reason is the speed is increasing at t equals 5.5 because velocity and acceleration have the same sign. And that's all you need for the conclusion. And basically, in order to get the 2 points, this is all your work that you gotta show. So moving on to the next problem. Next problem is problem B. It states that to find the average acceleration between 0 and 6. So what you would like to do is to write average velocity and then make it equal. So let me just finish that. And then equals 1 over 6, the integral from 0 to 6 via t dt. And you should be getting, hold on, give me a second to write it, you should be getting 1.949. So the way you do it is basically you go 1 divided by 6 because that is average, and then math 9, or you just want to scroll down to number 9 and there, and then from put 0 to 6, since we already have it on the y values, so I went to alpha trace y1 and then respect to x, and it still gives you as 1.949. So going back to our problem, now it's going to be problem C, which is telling us to find the total distance traveled by the particle from t equals 0 to t equals 6. So remember, it's total distance means we gotta use the absolute value instead of the regular, should be a t. So the total distance equals from the interval from 0 to 6 absolute value from b of t respect to dt. Then the answer you should be getting is 12.53573. So what you want to do, since we already graphed it, you want to go to math 9, then from 0 to 6, and then math, you want to go to math number absolute value of b of t. In this case basically it's y1 in my case, because already having the y values in respect to x. Now we should be getting the same answer, and note. And look at here, the same answer. Now going to D. So D basically from 0 to 6, the same thing. The particle changes direction exactly once. Find the position of the particle at that time. So what you want to do is basically make a velocity equal to 0. And velocity equal to 0 is at 5.19552. And let b equals 5 is basically let b when velocity equals 0. And the reason for that is basically it's because b of t changes sign from positive to negative at time t equals b. And now we can see how to solve it. Basically you want to graph it, and then you want to second trace, go to 0, and then you do left bound, right bound, and then you should be getting 0. And then let me write this explanation. Now basically x of b, so what you want to do, since I already gave x of 0 equals 2, so we put in initial condition, which is 2 plus integral from 0 to b, and b is the b of t equals 0. So and basically b velocity dt equals 14.134. So what we're going to do, we want to storage the 0 value at velocity, and then we're going to do 2 plus 0 to whatever number that we stored. In this case we did a, so alpha a, and then 0 to alpha a, then y1 dx. Now this concludes everything. Thank you.